Hi students, we're going to look at vectors again. This time we're going to look at unit vectors, and we're going to express them not only in component form, but a new form called linear combination. Now a unit vector simply means the magnitude is 1. Sort of like if you think about the unit circle, that radius is always 1. It's along the same lines, and here is a mathematical formula for that. It has u with this hat. We call that a hat over. It means that's a unit vector. That's how it's denoted. And here's the formula. All you're going to do is divide each point by the magnitude. Now this looks kind of hard, but once I show you a problem, I think you're going to be rather pleased. So here we go. The first problem says, let's determine the unit vector for 3, 4, vector 3, 4. So I like to draw it, so I want to give you a good visual. Most people are visual learners, so it helps. Okay, step 1 is let's find the magnitude. So to find the magnitude, as you know, I'm going to have to make this a right triangle. I know that the horizontal component is 3, this is 4. So if I use, what is that? A squared plus b squared to find c squared. The c squared is actually, or the c is actually my magnitude, yes? So I take the 3 and I square it and I get 9. 4 and I square it and I get 16. So that equals c squared. So the square root of 25, which is equal to 5, is the c. So that's actually my magnitude. Now here's the deal. They want the unit vector. They want to know if this was only 1, like this portion of it, from here to here, I'm just kind of guesstimating right there. They just want that portion of it. If the magnitude is 1, what would the corresponding value be on the horizontal and on the vertical? Super simple. Think about it algebraically. I don't want that to be 5. I want that to be 1. Sorry for that little snafu. I want that to be 1. So I'm going to go from 5 to 1. Don't you just divide by 5? In this case, I would, right? And algebraically speaking, if I divide that side by 5, I better divide everything by 5, correct? So now what I have is my horizontal component is 3/5, comma, 4/5 for the vertical, and I make the little component form v. So I've written that for you here. Just determine what value you would have to divide by to make the magnitude 1, and divide all components by that. And there you have it. That's my unit vector. Now we're going to get into something kind of hard. I tried to throw everything difficult I could think of into this next problem. So I begin by drawing it, and now I'm going to find out what the magnitude is. So let's just make the little right triangle. I know this is 6, and that is 3. It's really -3, but when I square it, it won't matter, correct? So 6 squared is 36, 3 squared is 9, or -3 squared is +9, which is a square root of 45, which is, by the way, sorry, the dog, 3√5. Oh, so my magnitude is 3√5. So I had to divide that by 3√5, and if I divide that by 3√5, I've got to divide the other two by 3√5. So if I were putting it in component form and I hadn't simplified yet, I might give this response. But as you know, we have to make the denominator rational. So on the first one, the first thing I'm going to do is simplify. This 3 becomes a 1, this becomes a 2. So I have 2 over the square root 5, and to rationalize my denominator, I'm going to multiply by √5 over √5, which essentially is just 1. I'm multiplying by 1, so I'm not changing its value, just simply how it looks. So now that the top becomes 2√5 and the bottom becomes 5. So that is the horizontal component. Now I'm going to divide both these by 3, and what I now get is -1 over square root of 5. Again, multiplying by 1 to rationalize that denominator, I get negative the square root 5, because it doesn't matter if you have an irrational numerator, just the denominator must be rational, over 5. And by the way, the square root of 5 and the whole root of 5 do not simplify. They don't share anything. You can't divide by 5 on either of those. So here's the deal. My horizontal component is 2 root 5 over 5. And my vertical component is this for the unit vector. But it says to express it as in linear combination. This is easier than you might think. All I have to do is I drop the little bars and I say 2 root 5 over 5 I plus negative root 5 over 5 j. That's it. This is linear combination form. So let me show you those again. This time I'm going to show those to you with some computation. So if I'm given 2i minus 3j and vector w is negative 5i plus 2j. Those are the same thing. I could express that as 2 negative 3. I could express that as negative 5, 2. That's all I have to do to go from linear combination form to component form. Now if I'm going to do this and double it, this would actually be 4, negative 6, you're just scaling it up, negative 10, 4. So I multiplied it by the scalar value of 2. If I had w minus 2u, which one's w? This one's w, which is negative 5, 2, and I subtract 2u, which is 4, negative 6. Just be really careful about the negative signs. Negative 5 minus 4 is negative 9. 2 minus negative 6 is that 2 plus 6, which is 8. So, done. That's how it works. You guys take care.